Hi guys, welcome back to part 2 of our face replacement on Comfy UI series. Last time we covered the basics of using Face Detailer to successfully replace the faces of images. Today we're going to dive a little bit deeper into the Face Detailer and go through each of the modifiers, and in the process correct a few issues from the last video. As usual, if you find these videos helpful, please don't forget to like and subscribe. And if you really want to support the channel, please check out my Patreon, where you can support with as little as $2 a month. It really helps cover the costs of making these videos, and soon I hope to be able to hire an editor which will allow me to put more videos out more regularly. Once again, thank you to everyone who's already a supporter. And with that, let's jump right in. So in our last video, we put together a workflow, which the link for the image file can be found below, and we were able to take this image and replace it with another face. Now, previously the results were still not quite there. We found that some of the replacement faces were not as high quality, they were looking a little airbrushed, and there was a little bit of artifacting going on with that. You'll notice here in today's version there is a significant improvement, and we're going to go through the modifiers and understand why we're now able to get a significantly better output. So as before, we are still only using the bounding box detector, which you can see plugged in here to the basic pipe, and then we are just outputting it using the face detailer. So let's go through each of these elements one by one. Starting with the top one here, guide size, you'll see here that this is 256. Now, what this is referring to is it's referring to the size of the area that is being cropped out to be replaced. In this case, you'll see here guide size for Bbox, meaning that the face detailer is taking the bounding box area, and if the bounding box area is less than 256 pixels, it will upscale that to 256 pixels. Now, you'll remember we are using a Stable Diffusion XL model. In this case, we're still using Dream Shaper. And as we know, the SDXL models tend to work better with larger image sizes. So we're going to go ahead and actually bump this up to 512. And so what is going to happen now is the face detailer is going to look at the bounding box area, which is this area here. And if this is less than 512 pixels, it's going to upscale it to 512. I'm also going to set the seed control to fixed so we can see what our changes are doing to the final output image. So actually, we've just made it fixed. I'm going to bring it back to 256 and generate that so we've got a starting point. Okay, so we can see here, once again, the output is not looking that great. Here's the original. Here's the output, and we can definitely see there's a lot of issues going on there. Now that we've got it set to fixed, let's go ahead and crank this up to 512 and see what happens. And you'll notice that there still hasn't really been much of an improvement. And there's a reason for that, but we'll get to it. Coming back, let's try and boost our guide size to 1024. And we're going to set the max size to that as well. Still no significant improvement, although you might notice there are some better detailing, but we're coming to that. And so you might be wondering if what I said before about the guide size having an impact on the image, why are we still getting crappy images? Well, and the reason for that lies in an area a little bit further down. So if you'll notice here, Bbox crop factor is set to 3. And if we look at the crop refined output and follow that down through here, you'll notice that it takes up pretty much the whole image. And so what is happening is a very small amount of upscaling is actually happening to the face, because the 1024 guide size that we're relying on is referring to the bounding box, which in this case is taking up the whole image. So if we adjust that by adjusting the crop factor, and a smaller number means that we make the crop area smaller, and we're going to bring this down to the lowest number, 1.0, and we plug that in, you'll notice that now the preview areas are actually cropped into the face. And we can see here that there is a substantial difference. However, we've gone a little bit overboard. And you'll even notice here that there is a line here showing the cropped area. So the trick with the crop factor is you want to crop in enough that there is enough focus of the area for the face detailer to work with, but you also want to give it enough room that it can pick up the surrounding context to better blend the image. So we're going to make it 1.5, and there we go. You can see that the image is now properly blended in. And if we look at the crop area, it's picked up a little bit more area around the face. We've got the hair, and then the actual area that's being replaced is the face. And so that is the purpose of the guide size and the max size. It basically looks at whether there is enough detail in an area based on the number of pixels. And if the face detailer feels that there are not enough pixels, it will redraw the area with the target pixel, in this case 1024. Now you'll notice in the previous video, when we tried to run this, we had to actually force Inpaint. And actually you shouldn't have to force Inpaint. So I'm going to turn it off. And we're going to run this again. And I'm just realizing it's not really going to show a difference. So I'm just going to randomize the seed so that we can actually show that it is running even though force Inpaint is off. And I will explain why in a moment. And you'll see even though we have forced Inpaint off, it's still creating a new face each time. And the reason for that is the way the face detailer works is it will look at the cropped area. And if it's below the guide size, it will determine that this area needs more detail. And so it will inpaint it or generate the new face. Now, if for whatever reason, the area that we want to inpaint is smaller than the guide size, we can still force it to inpaint by turning it on. And that's why we had to do it last time, because we were using SDXL models, which were generating images at 1024, and the base guide size that we had for this was 256. It was seeing the face areas as having more pixels than 256, and it didn't find the need to inpaint it, which is why we had to force it in the previous video. There's just one more setting that I'm going to go through, and under guide size, you'll see here guide size for Bbox. We can also change that to the crop region. So again, we are telling it whether to focus on the bounding box, which I believe is the bigger crop area, or the crop region, which is the smaller area, which is just the face. Okay, so I'm going to reset this to fixed so that we can continue seeing what set changes in the settings do to our image. The rest of these settings are very much the same as the K-Sampler. If you have questions about them, please check out the K-Sampler video. But we've got the seed control, the number of steps, the CFG, the sampler, and in this case, we're using Hewn. Let's actually bring that back to Euler. Now that we're using a larger guide size, it should work properly. Scheduler, denoise, this works all very much the same way as the K-Sampler. The next one here, which is not in the K-Sampler, is feather, and this basically tells you, and this basically is how much the image edges or the in-painted areas blend into the rest of the image. I typically keep that at 5. You might want to increase it if you find that your in-painting has very harsh edges, but we can't really see that here, so there's no need to touch it. Then we've got noise mask, and when you have this on, you're basically telling the face detailer only apply noise and denoise the area that we are masking. And to better show this, we're just going to have a look at the mask output. So we're just going to use a converter, mask to image, and then plug in a new preview. And we can better see what is happening in the back end. So we can see here what is actually happening is the bounding box becomes a mask, which is the white area, and that is the area that is noise and redrawn. And this is important because we will see this later when we try the SEGS and SAM models. So if we turn off noise mask, then it will actually try and apply noise and denoise the entirety of the image. So let's just run it so that we can see what an output of that looks like. And you'll notice in this case, not much happened because the base image actually already doesn't have any noise. So this would be useful if the image you're feeding into the face detailer still contains some noise, in which case it will denoise the entire image as well as the area that is being redrawn. Continuing on, force Inpaint we've already discussed previously. Now let's look at Bbox threshold. And this is basically the parameters that we are telling the face detection model to use when detecting faces. The lower the number, the more lenient the model will be in detecting faces. So in this case, the way that it works is the model or the face detailer is fed this image, it analyzes it, and it tries to determine a face with a certain percentage of confidence. I'm guessing something like this, it's picking it up, it probably has a 90-80% confidence that this is a face. If we take this bounding box threshold and crank it up to 90, that means that it will only replace faces that it has a confidence value of higher than 90. If we bring it down to 0.10, any face that it has a confidence of over 10%, it will replace that face. So this is useful if we have a situation where the model is struggling to find the face, or there's a lot of faces or a lot of objects that look like faces and you only want it to change the faces that it is most confident with. So for example, it could be an image of masks, and then those masks are in the background and there's a person in front of them. It could confuse those masks for faces. And so maybe in that situation, you want to crank up the threshold so that it doesn't pick up the masks and really only picks up the face, which is very clearly defined. Or vice versa. You want to replace a lot of faces in a crowd and they're not that well defined, and you can bring down the bounding box threshold to help it pick out these not so well defined faces. Next, we've got Bbox dilation. So what is happening here is you'll notice that there's an initial crop which takes up the face and the surrounding areas, and then it refines the crop to just the face. What bounding box dilation does is if you increase it, you're telling the face detailer, I want you to replace more than what is defined here in the refined crop. So let's go ahead and crank this up to 20 and have a look at what is being replaced. So at this point, we don't really see much, so I'm going to crank it up a little bit higher and be a little more aggressive so we can see clearly what is happening. Okay, so I had to crank up the dilation all the way up to 74, and the changes are still really, really subtle, but they are there. So we'll go through them. So if you notice here in the main image, if we travel up all the way here to the top of the head where we can see a little bit of the hair kind of flicking out, you'll see here that there's a little bit of light passing through and we've got some hair sticking out. And if we look at the side image over here, some blurriness has been applied here. If we look at the sides of the hair, there's a bit of change here. So it has kind of gone a little bit outside of the facial area, but it's very subtle. You might get better results by increasing the crop factor. So let's go ahead and crank that up to 2. And again, you can see the changes are really subtle. If we look up here in the hair, there's a little bit of change in the way the strands are falling, the way the hair falls across the face. I'm just going to drop it back down to 10 now that we've increased the crop area. And you'll see here, as I was right, the areas that we had pointed out earlier, the little bit of light coming through to the hair on the top here, the way the hair falls across, it's a lot closer to the original image, and the replacement is now really a lot more concentrated on just the facial area. This is probably not the best image for this, as the changes were really subtle, but I hope it gives you an idea of what's happening. Crop factor we've already discussed extensively. Now we move on to a series of settings with a new prefix, SAM. So if we come back to the basic pipe, you'll notice that there is an input for an optional model, SAM model optional. So we're going to go ahead and plug that in now. And if we type in SAM, we will see here SAML loader, and it will come with its own single model, and we're going to plug that in. Now you'll notice earlier we added a mask previewer to view the mask of what's happening. So if we just plug in the SAM loader and do nothing else, let's have a look and see what happens. All of a sudden, we see that by applying the SAM model, the cropped area is no longer a box, but rather a outline of the shape area. And that's what the SAM model does, is it looks at the bounding box area that we have selected and refines it into a well-defined mask. So it's a way of basically providing more precision when doing your face replacement. So in this case, for example, a situation where it might be useful is if with the bounding box, part of the hair was being eaten up in the box-shaped mask, and if for our particular image we were very happy with that hair and we didn't want it to be touched, this would be a really effective way of focusing that replacement on just the face. And we can see here what that output looks like. The hair is hardly touched at all, and the replacement area is really just the face and little more. So all of these settings pertain to the modification of that additional SAM model. Now, because it's a more precise model, there are a few settings here that help us manage how it's going to work. The first one here is SAM detection hint, and we're telling it where it should focus on looking for the face or faces. In this case, we've got center 1, horizontal 2, or vertical 2, meaning that we are telling it we've got 2 faces in a horizontal formation, or 2 in a vertical formation, 4 faces rectangular, diamond, or here we are telling it that there are already areas that are masked. And we'll do a separate video on diving into these different SAM hints and doing face replacements with multiple faces. SAM dilation, this works very similar to the bounding box dilation, where we're telling it how much area outside of the masked or focus area we want it to replace. So once again, let's crank this up to 50, and you'll see here by increasing the dilation, we've actually increased the mask area once again to almost go back into that box shape. And you can see here in the preview, it's picking up a lot more of the hair than it was before. SAM threshold, this works very much the same way as the bounding box one, but because of its nature of being a more precise model, the confidence level is set very high at 93%. Next, we've got the SAM bounding box expansion. So because the SAM model works on the bounding box and then it defines the face further, if we increase this bounding box expansion, let's bring it up to 50, you'll find it kind of tries to do something similar to the dilation setting, but not as well. As we can see here, it's not really picking up areas of the face. And what is happening here is you probably want to use this in conjunction with the dilation setting. We're telling it to basically look for face or for a face a little bit further out than what it's defined. So to better explain it, with dilation, we're basically telling it, you found the face, and I want you to work on an area around the face. For the bounding box expansion, the way that you might use it is if the bounding box has gone a little too aggressive on the face, and we want to tell it, you need to pick up a little bit more of the face beyond what you've detected, if that makes sense. So in this case, it is picking up a little bit more, but it's not really seeing face elements there, which is why parts of the hair are kind of see-through, because it's not recognizing that as part of the face. Then we've got the SAM mask hint threshold. And this one works in conjunction with the SAM detection hint, where we're basically telling it how aggressively to look at the hint. So if we're saying center, we're telling it to put 70% of its effort into finding a face in the center. If we were to make this 1 or 100, it would only look in the center for the face. I'm going to skip over SAM mask hint use negative and cover this in the next video that we do about SAM, because I still haven't quite gotten a grasp on this one. Next, we're going to jump into drop size. Now this one is really useful, again, for situations where you're replacing multiple faces, and what you're telling it is drop any masks that are smaller than 10. In this case, I'm guessing it's 10 pixels. So this is really good if, for example, you've got a situation where you've got a crowd and you just want it to focus on the larger faces and tell it just ignore any faces that are below this size. And that's basically it. With all of that, we've covered all of the key settings for using the face detailer. There is just one more thing I'm going to cover, and that is with the ultralytics detector, we've been using a Bbox detector. So we're actually going to plug in the SEG-M1. And in most cases, you can actually have both of these plugged in, because what will happen is, depending on the model that you're using, in this case, we've got the bounding box one, it will just apply the bounding box detector. And if you're using the SEGM model, it will use the SEGM output. So just kind of for learning purposes, we're going to throw in the SEGM person one, just so that you can see what it looks like. And you'll notice what's happening here is by using the SEGM person model, it's no longer just picking up the face, but rather it's creating a mask for the whole person. And we can see that mask here, we can see the preview here, and all of that has been replaced. So you'll notice in the original one, she's got kind of like this grayish sweater. Now it's kind of become this actually quite nice material, but I would say that the face quality has degraded slightly. And again, using this, we can play around with it and adjust the various settings based on what we've learned to try and get a better output. So ultimately, when using the SEGM person model, I had to make a few modifications to get a replacement I was kind of half happy with. I'm still not totally happy with it, and I haven't really experimented aggressively with this model. I'm assuming it will probably work better in situations where the subject is a lot smaller in the frame and not the center of the image in this big way as it is now. As this particular computer, I'm not able to get the guide sizes up higher than 1024. But what I did to get this output is I cranked up the denoise to 60%, dropped the CFG to 35, steps to 41, and I made sure to bring down the bounding box crop factor to 1 to really come in and crop as close as I could to the subject. But even then, you'll notice, there's a bit of a harsh crop up here, and there's still a few issues with the image I'm unhappy with. But with that, you should have a much deeper understanding of how the face detailer works. Now, there's other nodes that work with the face detailer that give us more information and more control, but once again, I will cover those in a separate video. With this one, you should now have a complete understanding of all of the settings in the face detailer and the main ways to feed images and prompts into it. I hope that this video was helpful. If it was, please don't forget to like and subscribe. And if you really want to help us out, please check out the Patreon. Thanks so much, and I'll catch you guys in the next one.